In this video, I'm going to be taking a look at this IBM 5151 monochrome monitor from 1981. And we're going to see if I can get it to work. Right now, I tried it out once and there's no signs of life whatsoever. This thing is completely dead. But let's see if we can bring it back to life. It's coming up right now on Retro Hack Shack After Hours. Well, hello everybody. My name's Aaron. Welcome back to the channel and welcome to eWaste Wednesday. That's right, eWaste Wednesday. Wednesday's the day where I go to eWaste and find things like this old monitor to fix up and see if we can get working. Most of the time we do. Hope that's not foreshadowing. But I was able to pick this up recently at eWaste, and I'm going to eWaste actually tomorrow. It's Tuesday when I'm recording this. I'm going to eWaste tomorrow, and I thought, well, I should better at least attempt to repair this, and then I can bring it back to eWaste or give it to somebody else at eWaste if it's not working or if I can't repair it or if someone just wants it for parts. Also, I should thank all my sponsors, all my patrons, I should say. All my patrons, thank you very much. And all my YouTube members also, thank you very much. YouTube membership, if you want to do YouTube membership, you can join up on my main channel, Retro Hack Shack. I really appreciate all of your support. And before I forget, I will say that this particular set cost me a grand total of, I believe, $15. So $15 for an IBM 5151. I think these things they're not too rare. You could probably pick one up for about $100, I'm guessing, on eBay. Maybe it's more than that now. I don't know. But yeah, I've got a couple of these actually, and I'm doing that big repair-a-thon or whatever you want to call it of all of those early IBM PCs on the main channel. And if I can get this working over here on the second channel, this would be a great monitor to display when I actually get those PCs working. So yeah, I want to see, for all those reasons and many more, I want to see if I can get this thing working. No, it really isn't doing anything. I've got the power plugged in back here to the wall socket, and I've got it set up because this thing doesn't have its own power switch. It's powered by the computer switch or controlled by the computer switch. You can still plug it in with an IEC plug, and then I've got that plug. I've got a little button over here that controls that plug. So we can go ahead and turn it on, and you can see what I saw earlier when I turned this on, which was nothing. So here we go. So this thing totally has power, no high voltage, no nothing, and no signs of life whatsoever. There's no need to plug it into anything. I can tell you right now, this thing is dead as a doornail. Hey everybody, Future Aaron here. I just wanted to insert that I totally forgot about a particular quirk of the IBM 5151, which makes this test invalid. Now, I'm going to remember this in a little bit, so don't take me to task too soon on this. I will come back and remember this. I swear my memory will start working in a minute, but let's get back to the video. But that doesn't mean we can't fix it. So I know already that I have to go ahead and open this thing up and check out the guts, and who knows, maybe it's something very simple. Maybe a cap failed open and replacing that cap will fix it, something like that. Who knows? Let's open it up and see what's inside. I'm not going to show you the whole disassembly, but if you're watching this at home and you want to know how to take one apart, there's some screws on the bottom, but there's also these hidden screws up here in this little grill area. And this thing always, the plastic is so brittle, it just always breaks. I fixed a bunch of these. You can fix them, but I don't know. Maybe there's a better way to take these out. Maybe if somebody knows a better way, you can share it with me. There it goes. I didn't, oh, yep. I was gonna say, I didn't break that one. No, I did. These little things always break off, and I usually just end up putting some tape or a little bit of E6000 glue in there to hold them back in. That's too bad. There's nothing you can do about it, though. Turn it over. Oh. Oh. Oh, no. Oh. That is not a good sound. Oh, man. Okay, the interesting thing about the noise I just heard in there, that awful rattling noise, is there's still the sealed sticker on here. Caution, do not open, warranty void if sealed. That's still intact, so whatever damage is in here didn't come from someone opening it up and doing something, I don't think. Because that sticker is still intact. Breaking the seal, breaking the seal. I can't go that low. breaking the seal, breaking the seal. Okay, here we go. Let's see what the damage is, literally. Well, here's a part of a metal shield that was glued on, so maybe that damage wasn't so bad. But I wonder if maybe over time this fell off and shorted something too. That could be a possibility. That could blow a fuse or something. So I feel like I thought there might be more rattling around in there, but I think that's all it was. I think it was just this rattling around the tube. All right, so we're going handheld to take a closer look here. You can see there's not much to these 51 and 51s. Once you add the color circuitry of the 5153 or the 5154 CGA and EGA monitors, things get much more complicated and the circuitry gets much more complicated. But basically, you know, it's just a monochrome CRT kind of thing. And so you've got, you know, the main board over here, and then we've got a transformer down here. And I'm not exactly sure what's in that. I can't remember, but I think it says 250 volts. So be careful. Got some high voltage stuff there. And that's pretty it. But take a look at some of this. Look at this anode cap. Wow. Could it be that this thing just fried at some point and blew up? I mean, that all looks like dust, kind of corrosion or something on there. It doesn't look like necessarily fire or anything, but it just looks really nasty. Otherwise, you know, the board looks okay. I'm going to have to take a closer look at this, of course. It's very difficult to see in these lighting conditions, but I'm not seeing anything that looks, you know, particularly horrible at this point. I need to see if there's a fuse on this thing, because it very well could be that metal shielding thing came off. It's just like this one over here. And, you know, yeah, I don't think that's supposed to be there. So yeah, those little pieces of metal that were probably on the bottom of the CRT or something like that, or on the bottom of the case down there, those just came off and started rattling around. So I think, you know, that definitely could have caused a short if that happened while this thing was powered up. I just want to see, I'm just kind of curious if there's a dead short. Well, there's probably not a dead short, because it would have blown a breaker or something on the load and neutral, the AC side of things here. Yeah, I'm getting about 17 ohms. That could be a capacitor, so it's probably okay, but something I'm going to keep in mind as we go through this. Maybe that's an indication of something else going wrong. Oh, nobody likes it when things go wrong, especially when ordering PCBs. That's why I recommend the sponsor of today's video, PCBWay. You know, PCBWay builds high-quality, low-cost prototype PCBs that you can order simply and easily on their website. Not only that, but they do PCB assembly and 3D printing, CNC milling, and so much more. Check out PCBWay for all your PCB needs, and I thank them for sponsoring the Retro Hack Shack After Hours. Okay, well, I've got this all apart, and I've done a thorough visual inspection of the board, which luckily we can basically disconnect everything and take the board out. I've done a visual inspection of the board. I don't see any obvious faults. So nothing like, you know, scorched. There's no leaking capacitors that I can see obviously leaking. You know, we'll have to check those perhaps if we get that far and see if that's bad. There is a lot of brown gunk here. This is the paste or whatever that they use to like hold down some of these coils and whatnot. And you can find that around the board a little bit, but mostly it's over here in this section. I know that might be a little hard to see, but sometimes that brown gunk can be corroded. But I did test it with the meter by putting the probes very close together, but not touching, and just seeing if perhaps this was conductive. And it doesn't seem to be. And it makes it a little bit difficult that it's around these coils, because if you test the underside of the board, back here, if you test these connections, well, it's a coil, so it's going to measure very low resistance anyway. I don't think that this brown gunk is causing a problem, but again, it's something to note, something to be aware of, and might have to come back to that. So what I thought we would do is go ahead and start from the outside in and just start testing things, because it's almost like this thing is not getting any voltage at all. And so maybe it's a bad fuse or something like that, something simple. What I thought the best probably course of action, since there's nothing on the screen, no sounds of high voltage at all, let's start from the power cord and work our way in. And the first thing that is kind of in the path here of the electricity coming into the system here is a fuse right here. I know it's a little hard to see because it's behind this big transformer, but it's a 250 volt fuse at 0.75 amps. And there's also, this is where the external power cables actually, they feed around and they connect to the system right here as well. So that's why they have the high voltage here kind of protected with this piece of paper. But I went ahead and took a little screw out that was holding this on, and we can pull this back. Again, I apologize because you're not going to be able to see it. Tell you what, I'll take a picture of it from this angle, and then you'll be able to see what I'm talking about. So what I'm going to do very carefully here is kind of hold this back because it wants to flop over like that. I'm just going to test the fuse, and we're looking for conductivity here. If the fuse blows, of course, it'll be open, but there should be a connection here across this fuse. Yeah, there is. That fuse is good. No problem with the fuse. However, what I am going to do while I have this open is rotate the fuse back and forth just a bit, because I have seen where the fuse gets corroded or something like that. The contacts get corroded around the fuse, and it can cause a bad connection or an intermittent connection just due to either corrosion or dust or whatever between the fuse and the fuse holder. So I'm just going to like rotate that fuse back and forth a little bit just to make sure that that is not happening. Oh, and you know what? This is not in a fuse holder. So yeah, there's no chance of that happening, but I have seen that from time to time. So yeah, since it's soldered in there, it should be good to go. I measured the primary and secondary side of the transformer, and I'm getting some resistance on both windings. So I can actually put this back into resistance mode, and you can see right now I'm hooked up to the secondary side of the transformer, and there's about an ohm there, and there was a 16 ohms on the other side. So there's some resistance there. Remember, this is just a wire, so it's going to read very, very low resistance. But let's go ahead and turn this on, and then we can look and see what kind of AC voltage we're getting through the transformer. Whoops, that's on DC. There we go. And so let's go ahead and turn this thing on, and there we go. So we're getting about 23.8, 24 volts. Something close to 24 volts, so that's looking good. The transformer seems to be working. And if I look at the schematic here, if you look at this S1 coming off of the secondary side of the transformer, they got primary side and secondary side, and it kind of makes its way over here. And you can see right here, they call out that this should be 24.6 volts. And this is after it goes through a diode, which shouldn't hurt anything. And I don't know if this is before or after this 1 ohm, 5 watt resistor. I'm assuming it's before, but they're getting 24.6 volts here. That's what they expect to see. So I think this is well within the range of expectations. So the rest of this part of the power supply is mostly on the board, with the exception of this TR24. I think that's the horizontal transistor there, the big heavy horizontal transistor. That one is not on the board. So you probably can't see this, but right in there it says power, and it says it on the back too. They've got this nicely laid out so that the components are all in their little boxes. This section up here says vertical, and that's in its little box. But this is the part of the power supply here, this section here. And so we've got like those resistors I was talking about before, like the 1 ohm 5 watt resistor is one of these here, and probably this one. And then there's the bridge rectifiers and all that stuff is down there. So what I'm going to do now is I'm just going to test all of these with the multimeter, the ones that I can test, like the diodes and stuff, make sure those are all working. And then we'll hook this up, because the other, that TR24, which I think the horizontal driver is down here, and it's in like a TO package. It's a big round package, and that's actually mounted down here on this metal, because the metal has to act as a heatsink, because that thing will get hot, obviously. So that could be a problem, or one of these components on the board could be a problem. But again, we're starting from the outside, working in. So I'm going to test all this stuff, and then we can hook it up and see if I don't find anything wrong. We can hook it up and see if we're at least getting the 15 volts. Again, going back to this, we should be getting 15 volts at the end of this power supply feeding into the rest of the board. So that'll be the final test. If we're not getting 15 volts, then something that I didn't test is wrong, like the horizontal driver or one of the caps. Okay, I've got this pretty much put back together, not all the way, but enough for a test. And I just remembered something. Getting old is not good, guys. I just remembered that I believe that with the 5151, there's no oscillator on board. And so if you don't have a computer connected to the video input, it may not generate high voltage. I think I remember that, and I should have remembered it earlier, and we just went through this whole thing, and that could be for nothing. My plan is still sound, I will say. If you have been screaming at the TV this whole time because I forgot something about one of the many computers I work on. I'm so sorry. But I think that for this next test, instead of powering this up and looking for that 15 volts I mentioned before, I'm going to get out a computer and plug this in and see if once it has an oscillator that the high voltage starts up. So this is a quirk of the 5151. Most monitors will have their own oscillator. The 5151 did not, and it got the oscillator, I think, from the video signal that was coming from the computer. So without that, it's not going to start oscillating, and you're not going to get high voltage. Well, you know, live and learn. Basically, let's not jump to assumptions though too quickly here, but I'm pretty sure that is going to be the case. All right, well, it's hooked up in the back, but the cover is still off just in case. I don't want to go through the effort of putting the cover back on if this doesn't work, and I've got it hooked up to one of the ports. I think I've got my graphics card set for MDA mode. I'm not sure which port is which. This is a graphics card with two outputs on it. One is one is MDA and one is CGA, and there's a little switch in the back that you have to switch to put it in the right one, but you also have to move the physical port on the back, the cable, to the other port. So hopefully I'm on the right port. Let's go ahead and turn this on and see if we get high voltage. Here we go. No, I don't think so. Oh, look at that. Are you kidding me? That was the problem this whole time. Now we got to fiddle with the controls here. Brightness doesn't seem to be doing much. It does a little bit. Oh, that's not good. Turn it off. So we just lost horizontal deflection there as we were fiddling with the controls. That was the issue though. We weren't getting oscillation. Okay, I've just twiddled some of the pots that I could reach. I can't reach all of them with the board the way it is right now, but I just kind of twiddled them to make sure that they're hopefully getting a good connection. They probably all need to be cleaned, but let's just try this again. See what we get. Should be getting a raster, and hopefully we're not getting that vertical line there. Anything? No, I'm not seeing anything. What's going on? Should be getting a raster. Now we should be getting a picture. Okay, so we know probably something happened with the horizontal, or it just lost sync or something at the end there. We were getting a raster, and then it just went away. So there's maybe a loose connection or something's going on. I'm not sure. So I'm just want to go back to kind of where we were before I remembered what I forgot, which is I want to see if that 15 volt is coming out of the power supply section. And that should be on T1 of the horizontal driver transistor here, TR24. So T1, I want to look on T1 and see if we have 15 volts there. So let me change this to 5 volts per division. Okay, so we should see if we have 15 volts, it should show up here. I'm gonna go ahead and turn this on. Got to be careful because this is live now. And let's just see what we have. Here's where that horizontal driver transistor plugs in, and we've got nothing. We've got nothing. So the question is, do we have sync? But let's check that 24 volts that we saw before. So on T3 we should have 24 volts, which is just right over here, a couple pins over. Let's see. Gotta look with my eyes. Okay, so on T3 got like 250 millivolts or something. Definitely, or 200 millivolts, 250 millivolts. So definitely nothing going on there. So either that driver transistor blew, because we did see that vertical collapse, or there's the computer booting up, or there's no sync coming in. And sync should be on pins, I think 8 and 9 coming in on the video connector, and hopefully they have these marked on the back here. They do not have these marked. So the only thing I see is a little bit of a signal on this one pin here. Okay, so I've traced these out, and it turns out that 8 is horizontal and 9 is vertical, and 8 was the only one where I saw activity. So we are getting a bit of a pulse, an intermittent pulse on pin 8. So that may indicate that actually we are getting sync, and the problem is perhaps that horizontal driver transistor. So what I want to do just to verify that is I'm going to hook up the 5151 to monitor and my RGB to HDMI and just make sure that I am getting video out of that MDA port. Okay, well, hopefully you can see that. That's coming out of the video card, and I think I had the settings wrong on the video card and was feeding a weird signal into the monitor. And hopefully that didn't break the monitor, but that explains why we weren't seeing what the monitor was expecting to see. Now I've got it set up. I'm in MDA mode on the RGB to HDMI. I'm on the right port. I've got the switch on that video card set in the right setting. So I believe we're in MDA mode now. So I'm going to hook the actual monitor back up and see if that makes a difference. Okay. I've got it plugged back in the way in the same port that I had the RGB to HDMI. We know that was working. We saw it on the screen. So let's see what happens. Come on, give me a raster. And I did switch these in case you noticed. I had these flip-flopped at one point. I think that's the way it's supposed to go. I'm getting a raster. Let's let it warm up a little bit. Anybody? Raster, raster.
Bueller. Bueller.
No. No. I think I blew it up. Man. So if I had hooked this up correctly in the beginning, this would be a non-video. But because I messed it up, now it's not working. You can see we've got no high voltage. It's picking up my voice. There should be high voltage up here at 13 kilohertz or so. And there's not. So I busted it. Okay, well, this thing was obviously working for a little bit and then stopped. And it definitely looked like we lost the horizontal driver because at the end the screen went to a vertical line before I turned it off. So I'm guessing we lost the horizontal driver transistor, but we can take a look at that and see. Because that horizontal driver transistor is connected directly to the board right here. I don't want to touch any of these just in case the capacitors are charged, but it's connected right here. And luckily on the schematic, it lists exactly what these connections are. They're broken down into T1, T2, and T3. T1 is the collector, T2 is the base, and T3 is the emitter. So we can actually test between emitter and base and collector and base, putting the negative probe of a multimeter set in diode test mode on the base. And what we should see is about a half a volt or so on the meter here. So right now I'm touching T2, or I should be touching T2 with the negative side of my probe. And with the other side, if I put that on there, ooh, not good. 0.088. So that is low enough that it has me concerned. If I was getting like 0.4 volts or maybe, 0.6 or 0.7 volts, I would think that's okay. But 0.08 is not okay. So let's go ahead and take a look at between T1 and T2. That looks more normal. And also this is in circuit, so there may be some capacitors as well around here. So you have to keep that in mind. But just looking at this, the way it is now, between the emitter and base, I am seeing a bad connection. So I think the next step is going to be to replace the horizontal driver transistor. And luckily, I just ordered some, and they just arrived today. Now, I wasn't actually going to show me replacing the transistor, but then I tipped the monitor up on the front of the CRT here so that I could get to the bottom. And it's kind of interesting. There's got this like little board where those wires connect to the horizontal driver transistor. And so I'm not sure what that board does, if anything, but the transistor is screwed through here, through these little terminals here. And then it's also screwed back through the other way to hold the board against the plate. So, I mean, I don't know. I've never seen anything quite like that before, but I'll have to desolder these wires and unscrew everything to get the new one plugged in there. Okay, well, after starting to desolder this and taking a closer look with my phone, I now realize why this is there. So there's actually the legs of the transformer are these kind of pointy pins coming out right there. And what's happening is this little board actually has some press fit connections built into this little PCB here. So that means that I can take off just the transformer from the other side of the board without having to remove any of these wires or take this little board off of here. If I take out these two screws that are on top of the transformer, the whole transformer should just unplug, and then I can plug the new one in there. All right, well, the mystery continues because I pulled out this suspected bad horizontal driver transistor, and when I measure it now out of circuit, see if I can do that, I'm getting 0.73 volts to one way. I can't remember if that's the emitter or the collector, but then it's hard to do this way. If I look at the other connector, then I'm getting 0.56. So I'm getting exactly what I thought. So maybe this horizontal driver isn't bad after all. I'm still going to go ahead and replace it with a new one just in case there's something marginal here. But yeah, I'm now thinking that this is not the problem. Okay, I've got the new horizontal driver transistor in there. At this point, I'm not thinking this will help at all, but let's just go ahead and turn on the computer and see what happens. Now, I would have thought at this point we would be seeing that green raster if things were working, but let's just go ahead and let the computer boot all the way up until we know there's graphics on the screen. Okay, there it goes. So, should be graphics on the screen. There is nothing. So, something else is wrong. Okay, well, more interesting things. Not only, as I talked about before, at this point up here, am I not getting 15 volts, and not only am I not getting 24 volts, I keep working my way back through the circuit, and I thought, well, let's go back to the very beginning, or near the beginning, where this transformer is, and check the output of the transformer coming into the board here. And so here's S1 and S2. Whoops. So I've got my meter set to AC mode, and here are the connections coming off that transformer. Whatever we saw before, I can't remember, we should be seeing here still, because certainly that is not affected by the circuit, and I'm seeing nothing. So either the fuse has blown or the transformer has blown. Time to check the fuse again. If the fuse is blown, I'm wondering if there's something on the board that's causing it to blow. In other words, there's a short somewhere in the circuit that is putting too much current through that fuse, and that's causing it to blow. Okay, all right, so very carefully get in here and just touch both sides of this fuse, and, ooh, yep, meter's working. The fuse is not. The fuse is blown, so now I've got a source 250 volt fuse from somewhere. Okay, so while I've been waiting for the fuse to come in, because I didn't have a 750 milliamp fuse, I just had 500 milliamp or 1 amp, and I really want to go ahead and match the spec on that because I don't want to drive components too hard or not, you know, have enough leeway there if I used a smaller fuse and just blow that fuse too. So while I'm waiting for that, I decided to go ahead and test what could have blown the fuse. Why did it blow? Why did we see an image and then the horizontal collapse? I think those are the clues here to go on. And so I started testing out the horizontal part of the circuit. Now, we'd already tested out the power supply part, and I wanted to go ahead and test out the horizontal because we saw the horizontal collapse there into a vertical line. So I was going through some of the components, and I noticed that there was some strange resistances across one of the diodes. I pulled that diode out, tested it, it was fine, I put it back in, and then that led me to test the horizontal output transistor. Now, I think before, when I was talking about that regulator back there, I think I was calling that the horizontal driver. That is in fact the regulator for the circuit, and there is a horizontal driver, but it's not that big round thing that I replaced earlier. So correction on that. Some of you will probably have noted that and already left a comment in the comment sections, but I'm going to correct it here, correct my mistakes. So, but there is a horizontal driver transistor, and there's also a horizontal output transistor. And that diode that I noticed that I was testing that looked weird was connected to that transistor. And so I went ahead and pulled it out of the board so I could test it. What I noticed when I tested this using my multimeter, the forward voltage on that was reading about 100 millivolts instead of 500 millivolts like it typically would, or around 500 millivolts. And it was reading that in both directions on this transistor. So yeah, took that out and got my handy dandy transistor, one of these cheap transistor checker things, and put it in the component tester here. Closed the thing, turned it on. Let's see if it's still telling me the same thing as it was before. Yeah, two resistors for this. So that's telling me that this is most likely marginal, and maybe that's what happened is that because it was so marginal, it worked for a while and then blew the fuse because this wasn't working correctly. So what I've done is I've gone ahead and gotten another replacement transistor, and if I put that in and close that and hit the test, there we go. We have an NPN transistor, exactly what it's supposed to be, and it shows the readings for it and everything. So I hope that perhaps this is the actual culprit of why that fuse blew the way it did. So I'm going to go ahead and replace this, and then when the fuse comes in, I'll go ahead and replace the fuse, and we can test this out. All right, the new fuse is in place, temporarily at least. I had to bodge one in there, but it's fine, I think. And so it's time to see what happens. Let's see if we get anything new or different on this monitor. Here we go. 3, 2, 1. No smoke yet. We'll see. See what happens. And we're looking for a raster. Oh, getting a squeal. I'm getting a raster. I'm getting a raster. Turn it down. Turn it down. A strong raster. Look at that. Nice. Turn the contrast up. The squeal went away. Turn the brightness down. That's perfect. It's working. It's working. I don't know if you can see that flashing cursor, but it is definitely working. Let's see if it stays working. Come on, baby. Yep. There it is. 601. Yep. Working. Completely working. Oh, that's refreshing. I've had so many problems lately with IBM PCs. I forgot what it's like to actually have one that you diagnose and it kind of works the first time. So this is really nice. I'm afraid I'm going to have to do a little bit of tuning here, and I'm going to have to do this off camera because I have to put on different glasses so I can actually see the screen. But right now, this is looking really good. So that whole problem with this set was not necessarily a bad or blown transistor. It wasn't shorted between the terminals, between the legs of the transistors, or completely open. It was marginal. It was marginal. And that's what the problem was. And that overloaded the fuse somehow. I'm not going to tell you that I understand all the magic that goes into these analog sets, but somehow that overloaded the fuse. And then we fixed the problem that caused the fuse to blow, fixed the fuse, and here's the result. A completely working 5151 MDA or monochrome monitor. Lovely. Love it. Love it. And I've done some more inspection with my various glasses that I have to wear. And I mean, I think the only thing that's wrong with this is as I was tuning it, or as I was working on it, I think I've got the sub brightness a bit too high, because when I turn the brightness up all the way, it really looks high, and I don't want to blow this monitor. So I think I'm just gonna, what I've done is I've got this just so I can just see the raster coming in, and I'm going to adjust the sub brightness down till the raster goes away. And then hopefully that is enough to do the trick. Let's see. Oop, that's getting brighter. I want to go down a little bit. Raster is almost gone. And yeah, I think it's gone. I think that's good. So now if we turn the brightness up, that raster will come back. Actually, I think that raster should be a bit brighter at full brightness. Let me just turn it back up just a little bit. Doesn't take much. Yeah, like that. Like that. And that was just a tiny, tiny turn. And got that back in. Okay, there we go. To me, I mean, that is super bright. I could even turn down the contrast a bit, but right now I've got it up all the way. You all will be able to tell better than me, but right now all of the characters on the screen are crisp and sharp, and I'm not seeing the raster anymore. That's gone. So we've tuned the brightness down, and then I've just turned the contrast down a little bit just to take the edge off it. And even with it all the way up, I don't see a whole lot of blooming. There is a little bit, of course, because we're really driving it now. But that's not even that bad. I still would like it a little bit lower than that. So yeah, I'm really happy with this. I don't think I need to tune anything else. I think I just need to put this back together and give it a once over, give it a really good cleaning, and hopefully this set will last for years to come. While I was cleaning up, working on this episode, I happened to find this copy of Byte magazine from January, I believe January 1982. And I just thought it was very interesting. This is their coverage of the launch of the IBM PC. I think they had some preview articles like this is coming or whatever, but I think this was the first one that really talked about the IBM PC, the very first IBM PC as it came out. And that monitor's all cleaned up. And as you can see, we now have our very own IBM PC running that. Well, it's not the same program because I created that program from scratch. I don't know what program they were using. I tried to use the dealer demo. That wasn't quite right. So anyway, I just created a basic program and put the IBM personal computer on there, as you can see. So the monitor's all clean up and looking fantastic. I got the Velcro stuff off the side. Really curious what that Velcro would have been for. If you have any ideas, let me know, because it went kind of in an L shape around here. Was that holding some like disc holder or something that you could put your 5 1/4 inch floppy disks in on the side of the monitor? I hope not. That's kind of dangerous with all of the stuff going on inside this monitor. It might affect those disks. I don't know. Let me know in the comments what you think that Velcro on the side here was for. But this cleaned up really nicely. There's still some issues with it in that I think there's some either bad caps, dodgy caps, or bad resistors that aren't bleeding some voltages fast enough. And what I mean by that is you'll see when I press Control-Alt-Delete on the keyboard here, you'll see that number one, the graphics tend to like linger on the screen and don't go away right away. And also you'll see this vertical line appear as I do that. So let's just try that and you can see what I mean. You see that vertical line? It kind of went down. There was a squiggly. There it is again. I don't like that. And then of course we're rebooting, but hopefully you could see. I don't know if it came across on camera, but I'll try to do it one more time in close-up mode. All right, so here we go. Control-Alt-Delete. See that line? And then it comes again. Another line, really bright. And then it goes back and reboots and everything. I suspect either a dodgy cap or a dodgy resistor. If you've seen that before on these types of monitors, let me know as well, and maybe I can go back in and do some more work. But for now, I'm pretty happy with the way this came out. All right, so what do you think about the repair on this monitor? I'm really excited and happy about it because it's one of those things that I was able to troubleshoot and, you know, found a marginal part, which usually, if I find a marginal part, that's usually not the problem. But I found that marginal part, we got this thing working, and now it's ready to go to a new home. So thanks everybody for all your support and watching my videos. I really appreciate it. If you want to see more videos like this, I'll leave a couple videos over here on the side of the screen, and I'll see you in one of those videos next. Thanks for watching. Bye-bye.
End of line.